Our topic today is talking about comparing scientific notation. We have already learned in class how to turn numbers into scientific notation and how to turn numbers that are written in scientific notation back into standard form. So today we're going to be talking about comparing scientific notation in standard form. And we're going to do that by converting numbers to the same form so that they're easier to compare. It's kind of like when you have a fraction and you have a decimal, and your teacher asks you to compare those. It's easier to either turn the fraction into a decimal and then compare it, or turn the decimal into a fraction and then compare it that way. If they're in the same form, it's easier to do. So in your notebook, write down a heading, comparing scientific notation, and our objective is I can compare numbers written in scientific notation and standard form by converting numbers to the same form. That's what we should be able to do by the end of class today, or by the end of your lesson today. So once you have that written down, let's move on. I think you can I think you can fit these notes on that same page in your notebook. So number one, the first thing we're going to do is convert the numbers to correct scientific notation. Now this is really, really important because you'll see a lot of fakers out there. So what is a faker in the world of scientific notation? A faker is something like perhaps 63.2 times 10 to the second. Okay, this is not truly in scientific notation because my first number, the decimal part of my scientific notation, is not a number between 1 and 10. It's actually 63.2, and that is not okay. This is not scientific notation. So the first thing we have to do is turn all of these fakers into numbers that actually are scientific notation. And I'll show you how to do that in just a few minutes once we're done getting these notes down. So step one is convert them to correct scientific notation. Next, we are going to look at the power of 10 to see which number is bigger. If I have 3 times 10 to the 8th power and 4 times 10 to the 3rd power, I am going to very quickly be able to see that this one, 3 times 10 to the 8th, is a bigger number because 10 to the 8th, my gosh, that's huge. That's a 1 with 8 zeros after it. Well, 10 to the 3rd is only a 1 with 3 zeros after it. So clearly, this number here is going to be a bigger number when if you were to take that and put it into standard notation. So if, however, our powers of 10 are exactly the same, maybe they're both 10 to the 3rd power or 10 to the 8th power, well, then we're going to have to take a look at the first part, the decimal number, and whichever decimal number is bigger is going to be the larger number. That's only if the power of 10 is the same. So get those notes down, pause the video if you need to, and let's go ahead and look at a few examples. So our first example is 37.2 times 10 to the 6th compared to 3.74 times 10 to the 6th. If you remember what our first step is to convert the numbers to correct scientific notation. So we have to correct any fakers that exist. So let's find out if we have a faker. In scientific notation, our decimal part has to be a number between 1 and 10. If we look over here, well, yeah, that's good. 3.74, that's a number that is between 1 and 10. But if we look at our other number, 37.2, that is not a number between 1 and 10. 37 is much bigger than the number 10. So we have to fix this number and turn it into correct scientific notation. So we're going to take our decimal place, just like if we were converting a regular number, say 3,600 into scientific notation. We would take a decimal point and bump it over. Well, we're going to be doing the same kind of thing here. We are going to take our decimal point in 37.2 and bump it over to be between the 3 and the 7. So our new decimal number is going to be 3.72. But we can't just leave our power of 10 the same because it's not 10 to the 6th anymore. When we move that decimal point over to the left, this ends up being 10 to the 7th. So now we are going to be comparing not this number, but comparing 3.72 times 10 to the 7th to 3.74 times 10 to the 6th. So when we do that, step 2 in comparing scientific notation, right here, is to look at the power of 10 to see which number is bigger. The one with the larger power of 10 is going to be our larger number as long as it's written in correct scientific notation, meaning this first number is between 1 and 10. So both of these numbers are in correct scientific notation, so we need to look at our power of 10, and in this case 10 to the 7th is a larger power of 10, so our number that is written, that is the larger number is 3.72 times 10 to the 7th. Sorry, my box is kind of funky there. Okay, let's go ahead, make sure that you wrote this entire example down. If you forgot to do that, go back and do that. And let's look at another example that I have for you. We have 4 different numbers here that we want to compare and put in the correct order. So if we go and we look at our steps, we need to convert the numbers to the correct scientific notation. Let me erase some of this extra pen mark so you don't get too confused. Okay, so we're going to convert the numbers to the correct scientific notation. But if we look here, all of our first decimal numbers, well, look at them. They already are correct scientific notation because those first numbers are between 1 and 10. So if we're going to put them in order, we just need to look at our powers of 10. That's the step 2 in comparing. We have a 10 to the 6th, 10 to the 3rd, 10 to the 4th, and 10 to the negative 8. Be careful with those negatives. A lot of you would kind of ignore that negative sign and say, oh, well, that's the biggest one because it has a power of 8. No, it's a power of negative 8, which actually means that this number here, 5.4 times 10 to the negative 8, that is our smallest number of scientific notation. Next, we have 10 to the 6th, 10 to the 3rd, and 10 to the 4th. 10 to the 3rd is going to go in our next spot, 10 to the 4th, and then finally 10 to the 6th. Notice that we never had, let me go back a couple, we never had to use this second step here. We never had, or sorry, the third step. We never had to look at the decimal number because all of our power of 10s were different in our example. So hopefully you wrote that one too. If not, go back and write it. Oopsie. Here's another example for you. Once again, all of our powers of 10 are different, but we have a problem. We have some fakers here. Fakers, fakers, fakers. If we look, let's start with this first one. The reason this is a faker is because the number 0.2 is not between 1 and 10. So we're going to have to move this decimal point over. Now we're moving it to the right to get the number 2. And our power of 10 is going to go down 1 because we moved our decimal place to the right 1. So this is actually 2 times 10 to the 5th. Here we have another faker. We have 34. Well, that's not going to work. That's not between 1 and 10. So we're going to take our decimal point, move it left 1, giving us 3.411 times 10. And our power of 10 is going to increase by 1 because we moved to the left. And then last but not least, we have this 88.2, which is also a faker. We have to move that decimal point over 1 so that we end up with 8.82 times 10. Oh, I'm out of room. Let me move that over. 8.82 times 10, and I moved the decimal point to the left, so my power is going to go up 1, and now I have 10 to the 6th. So once we've gotten rid of our fakers, we can start ordering based on the power of 10. So we have two powers of 10 that are to the fourth power. That's when we have to use our step number 3, where we look at the decimal number to see which one's bigger. So we have 7.5 times 10 to the fourth and 3.411 times 10 to the fourth. This one right here, my 3.411, is my smallest. And then I have my 7.5 times 10 to the fourth. If I then look at my powers of 10, my next clear one is going to be 2 times 10 to the fifth power, followed by 8.82 times 10 to the sixth. All right, finally, I want you to try and put these in order from least to greatest, and this is going to be your reflection question. So I want you to type in your answer to the reflection question into Edmodo when you turn in your assignment and put these 4 numbers in order from least to greatest. Be careful because all of these are negative exponents, so be careful with those negatives. And we also have a faker in here, so don't forget to fix that faker before you start putting them in order. All right, I look forward to seeing your responses, guys, and have a good night.